Hi, my name is Johannes Anak. My matrix number is CN170121. In this video, my final year project is development of aquaponic farming technology system using Arduino based on IoT, Internet of Things. My supervisor name is Professor Madya Dr. Jamaludin bin Jalani. I am student from Department JTKE in Faculty of Engineering Technology. Okay, for the abstract. Every farmer wants to work in a modern way as the age is getting increased and change way to better life. Aquaponic applies a variety of biological and ecological approach to agriculture and plant development. Arduino IDE software is needed to develop a coding for the Arduino to get through with various sensors, output device and other hardware. On the apps called Blink, it receives the data through Wi-Fi module ESP8266 ESP01. The training graph will be shown up and keep update. So next, for the introduction, aquaponic are in industry of raising aquatic organism up to final commercial production within properly partitions aquatic areas. Secondly, it is circulation aquaponic is essentially a technology for the farming of aquatic organisms and plants by reusing the water in the production. And aquaponic farming system technologies, or known as FS-Tech, is a great platform to demonstrate growth for the Industry Revolution IR 4.0. This project aims to expose the user, farmers and students about an aquaponic on farming system technology with the modern in the real world industry. In this project, the main operation is to control the water quality by applying sophisticated technology measurement and monitor the condition of water via apps through IoT. Okay. For objective in this project, firstly, it is to develop monitoring system in aquaponic farming based on IoT. Secondly, it is to establish controlling the water flow of effective communication in digitalization through IoT. In this project, I have been doing some research in the literature review. So, the project was proposed that electronic system will perform all monitoring, error correcting and user alert actions necessary to maintain the unit ecosystem. So, I refer for the articles automated aquaponic system. Secondly, the result of GSM is obtained by observing the message that sent out by the GSM to mobile phone. So every input the data will be sent to the GSM. So in this article, I refer to design of aquaponic water monitoring system using Arduino microcontroller. Lastly, the aquaponic system does not have to run continuously. However, the user can adjust the timing of the aquaponic cycle for optimal harvest as well as balance power consumptions. So this refers to aquaponic system. Next, methodology. So this is the method that I use to connect my hardware. First of all the input and output come from the Arduino Uno microcontroller. It will send the data through Wi-Fi module hardware, and then it will send data through my home portable Wi-Fi. So the data can be stored inside the cloud computing, and then you can access using your smartphone when you open the Blink apps. So this is the communication network that I use for in this my project. So if without using the Wi-Fi module ESP, so this is you cannot access when you don't have a Wi-Fi module. Next, this is the experimental setup. As you can see, okay, there consists of 4 input and 3 output device. So only 2 output device using 12 volt voltage for the motor pump and solenoid valve. So only one motor, they use 3 volt. Next, here is the some of the connection going to through microcontroller Arduino Uno. Next, for the result in discussion, as you can see, the pH value. Okay, when you start to measuring the pH value, so this is the average reading from 6 above, from the minute 1 until 5. It a very good trending. When it comes up, the water is changing on the condition. When you feed some food, or maybe the water comes with some waste from the prawn. Next, dissolved oxygen graph. So as you can see, when the dissolved oxygen graph, it will be false. Start minute 3. It means that the water is discharging from aquatic tank, so it transfer to other tank as well. So it will be rise and fall for the trending graph. The water keep refill, and then the water is out coming from the tank. Next, the controller. Okay, as you can see, the controller for the auto mode, when you turn off, okay, the water is refilled when the pump is on. So it means that the pump water in this area is a red LED. So it is indicated here as you see. So next, when the surface of the water level reach or nearly full, near to the ultrasonic sensor, about 3 centimeter, the valve will be start trigger, and then we show the indicator green LED. This means that it turn off. The water will be flow out from aquatic tank to the hydroponic tank. Next, for the manual button, as you can see, it consists of 3. First is pump, and then secondly valve, and then lastly is air pump. So if you press button air, it will turn on the air pump. When you turn off, it will off condition. So for the air pump, it does not have a problem at all. For the pump, when you turn on it, and then it will turn on off during short time. I have some problem for the manual button, pump and valve button. So for the controller part, I have some issue, which is the hardware cannot be latching on. As long as you press the button, then it cannot hold for running operation. Next, conclusion. In a conclusion, the project has met all of the state objectives of the project. Unfortunately, there are some issues on the controller part and networking have been occurring, especially Wi-Fi module. I have says that the something problem on my manual button and Wi-Fi module. Sometimes my Wi-Fi module problem, maybe it's what we call that, it the capacity capable is not enough to catch up for my coding. So the result revealed that this project is able to monitor the conditions of the water for the farming system technology. So next is a reference. There's 3 reference that I use in this poster. As you can see, the author C. Myler, C.Z. Murad, and M. Kemesik. So before I ended this video, I will show you about my project demonstration. So this is the sample of my video demonstrations. That's it from me. Thank you for my poster presentation today. Thank you. Banyak kan?
On lah. On lah, relay on. Okay, relay on.
Pun pakai auto lah.
Auto mode. Auto mode.
Graph lah.
Okay,
moving graph lah.
And by trend moving. So untuk monitor yang proses lah. This the process.
Bila pH habis effect, then this oxygen pun effect.
Yeah. Okay. Yang motor running ah.
Motor aku off kan.
Okay. On the motor lah.
Taping. Okay. Okay, dah kan. Air kan air manual mode off nak on. Off.
Okay, motor off.
Low pressure atau
Okay, level detect low pressure.